Hi, my name is Sameer Nori. I'm in the cloud and software ecosystem team in the infrastructure line of business at Arm. I'm excited to be here at Microsoft Ignite 2025. And I'm going to share how Arm and Microsoft are partnering to deliver cloud performance and efficiency with Azure Cobalt 100 Arm-based virtual machines. During the next several minutes, we'll explore why developers are building on Arm, the performance and efficiency advantages of Cobalt 100, real-world customer results, and resources available to accelerate your own cloud journey. At Arm, we have spent more than 15 years investing and building a software ecosystem that is second to none. Today, we have over 22 million developers building on Arm. Nearly all CNCF projects, almost 95%, support Arm natively, and we're working with over 1,000 open source and ISV partners. That breadth and depth means that when you build on Arm, you're tapping into a mature and robust ecosystem that's ready for enterprise workloads. So we work across various categories of the ecosystem, including major SaaS platforms and enterprises, AI/ML tools, and all major operating systems. Majority of the Linux system distributions are Arm System Ready certified, which means we work closely with Canonical, Red Hat, SUSE, and open source distributions in the community to be available with Arm support. Majority of the runtimes, orchestrators, CI/CD, and other DevOps tools also provide native ARM64 support across various cloud platforms. In the ML and AI space, we support leading frameworks such as PyTorch and ONNX, platforms like Databricks, and vector databases such as Zillis. So, why are cloud developers building on Arm? It really comes down to three things: performance, ecosystem maturity, and cloud optimization. Arm Neoverse cores deliver the best price performance in the industry. Developers have native tools and broad software support from the ecosystem that we just talked about. And these platforms are built from the ground up for hyperscaler environments, ensuring that you can scale your workloads very efficiently. So Arm and Microsoft have had a strong partnership for several years, spanning various areas, including IoT, the client space with Windows on Arm's laptops, and the server and cloud infrastructure space. In the server and cloud infrastructure space, the partnership is built on innovation at the silicon layer through the Arm Compute subsystem that enables Microsoft engineering teams to co-innovate with us and deliver Cobalt 100 to market. The partnership also extends into the software realm across various Microsoft software properties. We have lots of ongoing software engagements that bring you the robust set of tools such as GitHub Runners for Linux and Windows, Windows Perf, and others. We're also actively working with our software ecosystem partners to make sure their platforms run and are optimized for Cobalt 100. So the Azure Cobalt 100 Arm-based VMs have been available for some time now, and we are seeing strong adoption for a variety of use cases. The general purpose and memory optimized VMs are well suited to run scale-out Linux workloads and other cloud-native workloads. With these, you get up to 40% better CPU performance, 50% better performance on Java-based workloads, and 2x the performance on web servers, .NET, and in-memory cache applications. These are also more power efficient and priced to offer 50% better price performance compared to the prior generation. And as of September 2025, these VMs are available in 26 Azure regions and growing. So in the general purpose series, there are options for both 4:1 and 2:1 memory to vCPU ratios. The 4:1 instances are ideal for scale-out workloads, Kubernetes clusters, open source databases, as well as application and web servers. With the smaller 2-to-1 ratio, you can run gaming servers, media encoding, and other workloads that don't need high RAM per vCPU. Finally, for the memory optimized segment, you can get up to 8-to-1 memory to vCPU ratios. These are ideally designed for large databases, large in-memory caches, data analytics workloads, and machine learning applications. All the Azure Cobalt 100 VMs support both local SSD temporary storage options, as well as a range of remote storage options. So let's talk a little bit now about specific workloads and performance gains on Cobalt 100. You can expect to see significant gains across a wide range of workloads. For NGINX, you get almost a 2x performance improvement in your API requests per second. In the database space, for Redis, you see almost a 50% improvement, while with Postgres, you see 26 performance gain. For SPECjbb, you see a 53% better performance improvement. These gains are all over the prior generation of Arm-based instances. Now, simulation workloads are compute intensive, and in the EDA space, we see significant improvements as well, both for Perf per vCPU and Perf per dollar. For Cadence Xcelium front-end simulation workloads, you see gains in the 50 to 60% range, while for Siemens QuestaSim, it's over 2x. HPC is a segment in and of itself, and those workloads are also very compute intensive. Across the spectrum of engineering, molecular dynamics, climate and weather, and genomics, there are significant performance gains to be achieved by running these on Cobalt 100 compared to prior generations. In summary, the Cobalt 100 Arm-based platform is well suited for compute-intensive as well as cloud-native workloads and offers significant advantages, as you have seen. Let's hear now from two of our partners on their deployment of Cobalt 100 and the significant gains they're realizing as a result.
OneTrust is a software company which provides a unified platform for governance, risk, compliance. We also have strong focus on data privacy, security, and use of AI responsibly. So AI governance is our top of our mind right now. And my role at OneTrust is I'm a senior director for cloud engineering, where I'm responsible for all the infrastructure that runs our platform on. OneTrust is built on Azure. We are a cloud-native company. 95% of our environment runs on Azure. We have around 60 plus environments with 60 plus Kubernetes clusters. We use Cobalt for all of our Kubernetes workloads. We adopted Arm-based instances in the first generation of Azure Arm, and then we moved over to Cobalt last year. We've seen a significant improvement, around 65 to 70% improvement in our CPU utilization, in our memory utilization, with great performance. And Cobalt instances are great in terms of disk I/O, network performance, and CPU memory usage. Sure. We've seen around 30% cost savings wherever we adopted Cobalt. And since at OneTrust, we take cost very seriously, and this has been a huge improvement for our cost. We have around 30 plus regions, so we are looking forward to adopt Cobalt in all the Azure regions that we have to get to 100% adoption of Cobalt. And we also have quite a few number of VMs that we are looking forward to adopt Cobalt in.
Yeah, at Databricks, we run tens of millions of VMs daily across multiple clouds to power AI and data workloads for our customers. As part of that service, we onboard new compute offerings from these cloud providers for classic compute, where our customers are choosing the VM they will use, and for serverless compute, where Databricks manages it automatically on their behalf. Cobalt 100 is now a key part of Azure Databricks. And when paired with our Photon native C++ execution engine, we're able to really leverage the Arm-based cores efficiently. It's ideal for lakehouse operations and for serverless SQL. We see that Cobalt 100 provides 20 to 25% higher network bandwidth per vCPU, and this makes it especially suited for high throughput data pipelines. In our internal evaluation of Cobalt 100, we saw fundamental database operations such as reads, writes, shuffles, sorting, and network data exchange. Our median latencies were reduced by 25 to 35%, with many work patterns exceeding 40% improvement. Additionally, the increased network bandwidth alleviates a very common bottleneck for data lake workloads. It allows us to improve our overall cluster utilization rates and reduce our job completion times. In short, workloads run faster, scale more smoothly, and we achieve higher efficiency in real-world workloads, not just in our micro benchmarks. Because Cobalt 100 combines high performance per core with improved cost, we are able to achieve runtime reductions as well as compute hour savings, and this translates directly into lower costs for our customers. Overall, we see Cobalt 100 as a clear price performance win, higher performance at lower cost. Cobalt 100 is already the preferred compute for serverless SQL in many regions, and the rollout will continue globally so all customers can receive the improved performance automatically. We're also expanding Cobalt 100 across many more Databricks services, such as Lakeflow declarative pipelines for ETL processing and our AI ML engineering products.
So we spent a little bit of time talking about the product family and some details there, as well as some customer examples. Let's talk about how you can now get started with the Arm platform and some resources we have developed to enable you on that journey. Arm Cloud Migration is an end-to-end program we have developed and are investing in that comprises a software ecosystem dashboard, learning paths and tutorials, and migration tools to enable you to get started with migrating your application to Arm. The software ecosystem dashboard is a central repository of open source and ISV applications and helps you check whether a particular software or application can run on the Arm architecture. The dashboard by itself is open and collaborative, hosted on GitHub, and maintained with both Arm partner and developer contributions. There are currently over 900 packages listed, and this list is constantly growing and evolving. Learning paths are like recipes or cookbooks to help you get started quickly. There are over 150 learning paths or tutorials currently available to help you migrate, deploy, or optimize your workloads. These are also available as workshops and code-alongs that make these on-demand and interactive. Lastly, but certainly not the least, our experts are also available to help you on a one-on-one basis to help assess, plan, and guide your migration to Arm. For more information, you can visit arm.com/migrate. In the migration tooling space, we have a set of tools that can enable you to complete your migration faster and be more efficient. A comprehensive package of migration tools is specifically designed to help you migrate your applications and workloads to Arm servers. This package provides a unified installation of 13 essential tools for analyzing, optimizing, and migrating software to the Arm architecture. The Arm Linux Migration Tools package simplifies the process of migrating applications to Arm-based systems by providing pre-configured, ready-to-use tools in a single installation. All of these tools are optimized for Arm Linux systems and include proper dependency management through automated scripts. These tools include QBark Inspect for container image inspection, Arm migratees for analyzing and porting workloads, and Arm Total Performance and Bolt for performance reporting and analysis. At Arm, we are also closely working with Microsoft teams and have developed specific learning paths, code-alongs, and webinars for specific Azure services, and highly recommend you check these out as well. So it's also important to highlight that Arm and GitHub have a strong partnership that simplifies migration of your application to Arm. As you are building and optimizing your application for Arm, you can leverage Arm native runners for GitHub Actions for both Linux and Windows. Over 2,000 enterprises are using Arm runners in their workflows, and they cost 37% less than alternative options. The build times are also faster than ever before. In 2025, if I didn't mention AI, I would be remiss. And we also have in this space an MCP server that will be released in beta very shortly. And this can be used in context with GitHub Copilot and other AI developer assistants. Stay tuned for this space and announcement. In closing, I want to leave you with some resources on both the Arm and Microsoft properties across developer hubs, Microsoft Cobalt 100 product information, and GitHub resources that can enable you to get started. Thank you for taking the time to tune into this session, and I hope you have a great Ignite 2025.